Okay, so now let's go over into our API gateway, and let's open up API gateway here as well. We can actually just cancel the classifieds app for now. Go into, say, API gateway here, like that. And let's open up package.json. So in this one here, we're going to add a lot of stuff which allows us to actually build it and to do what we're going to use code deploy to automate. So first things first is inside of here, let's add in a couple dependencies. So we're going to actually add in yarn add Babel loader, and we're also going to add Webpack, Webpack CLI, and Webpack node externals. Okay, so now that we've added these, inside our scripts here, we're going to add in a build script. So the build script is going to be webpack -- progress. So this is just a very simple build script. And now let's right click here, new file, and let's create a file called webpack.config.js. Now for this file here, we're going to write const path equals require path, const webpack node externals equals require webpack node externals. So before I continue here, you might be like, wait a second, why are we using webpack for node? I thought webpack was for React. So what you can actually do is you can use webpack for node, and it does essentially what it does with React, right? It combines everything you've got into a single bundle file. Now, the benefit of that is that it prevents you from relying on directory structures. So for example, if you do like dynamic imports at runtime, for example, a require with a custom directory structure, it actually leaves you up to a lot of problems because not all of your code is in the same place, and one or more files may go missing during part of the deployment process, part of, files being on a server, that type of thing. So it actually is beneficial to have all of your code in one place, not to mention there probably is some sort of performance benefit as well because you're not relying on the file system as much. So we have this here, which basically bundles it all into a single file. Why do we use Webpack node externals? Because we don't want to bundle everything into a single file. For example, Node.js typically deals with quite a few possibly binary packages, binary node modules, and it's not really in your best interest to bundle all of those. So what you do is you keep all of the external dependencies separate whilst bundling all of your internal code. So that's what we include this for. Now we do module.export is equal to entry and then src index.js like that. Externals, we do webpack node externals as a function inside of there. And then we do mode is going to be production module, and we only have one rule here. So still write rules, but just one rule, and curly braces test. We're going to test for JS, and we're going to use the Babel loader. And then for our output, we're going to do output file name bundle.js, so into a file called bundle.js. And for our path, we're going to resolve into a dist directory. So just like that, and then comma, target is going to be node. So make sure you write this so that Webpack knows that we're working with Node.js. So now that you have this, you should just be able to do a yarn build inside of here, and it should create a file called dist bundle.js. Now, if we have a look at this file here, you'll notice that it has your GraphQL stuff and everything inside of here. But if we press Command S, it will actually format it for us because of prettier. And if we just do a scroll down, you see that it does include a lot of dependencies externally. So for example, Express, Cause, Cookie Parser, everything else gets included externally, whereas all of our code is inside of this one file here. So we can actually use that, which is really cool. So anyways, now we have this set up inside of API gateway, but now let's do the same thing inside of listing service and also for user service. So inside of package.json, we have build. Let's grab the same thing and put it into listings service. So exact same thing, go into listings service here, and just do a yarn add again, Babel loader, Webpack, Webpack CLI, Webpack node externals, press enter. Okay, so now what we're going to do is grab that build script, so copy that one line, paste it here, grab the whole of Webpack config, and you can literally just throw it there, no changes needed whatsoever. So now you should be able to do yarn build, and it should also create the same file inside of here. So we have dist bundle.js, but this one is the bundle for the listings service. So now we can delete that, and we can grab the same Webpack config, put it inside users service, go to package.json as well, and inside of here, we're going to add in this build script for users service, and go to user service here. Grab that yarn command, yarn add, and we're going to add that in. Let's test yarn build and make sure that works. So yarn build here. Oh, and one more thing to mention is that make sure that your dependency versions are the same or similar to mine. If yours are not, your code might work, but it also might not. So just know that that is a risk you might be taking, but I'm using Webpack major version 4, Webpack CLI major version 3, and Webpack node externals major version 1. So that's what I'm using here, Babel loader major version 8. Okay, so now that we've got that and it's building, seems to be working just fine. Anyways, so now we've got these three set up, is now we're actually going to create a custom internal node module, which we're going to use for our deployment. It sounds pretty cool, but it is definitely quite complex as to setting it up. But anyways, let's go here, create a new directory. I'm going to call this one node deploy. And now we're going to go into node deploy here. So node deploy here on the side, do yarn init -y, so that'll create a package JSON file for us. So now inside of this file, we can just keep it like this for now, but we just need to add in a bin script. So this is a binary. I'll show you what this does. So curly braces, and then we write node deploy src/index.js. So now that we have this, let's right click this, new file, add in src/index.js. And on the very top of this file, we're going to write usr bin env node. So what this does is this is the start of an executable script. So what we're actually doing here is we're saying that this file needs to be run using node. Now, why do we do usr bin env is because this basically gets whatever corresponds to the node keyword from the environment. So if we have node set up here, for example, my node corresponds to users Lucas nvm versions blah blah blah. So instead of having to specify that exact path, which can be prone to change, we basically get node from the terminal. So wherever node actually corresponds to, in other words here, that's the script we use to run this. So now we have this, let's keep writing inside of here. Let's go into package JSON again, and let's add in a few dependencies for node deploy. So let's actually just get rid of this one here. So we only have node deploy here. And let's do yarn add AWS SDK, date fns, and .env, and just note the versions that I use here. So make sure that you kind of use similar versions. Once again, if you don't, your code might work, but if it doesn't, it's really hard to blame me. So this is what we have here for the dependencies. Okay, so now we're going to go into index.js here. And now this is how we're going to do deployment for this project. On AWS, you can do a whole bunch of stuff. You can do like machine learning, you can do static hosting, you can put up EC2 instances, you can put up databases. It's really cool because it has all of this functionality. However, on another sense, it's also very bare bones in that it doesn't have a lot of things built in. And if you want to get, for example, a deployment process set up properly, it actually is quite difficult and quite messy to do, quite finicky. So I'm going to show you how to do that here for the sake of this project. And I'm going to write up this file specifically to work with our project requirements. So I'm going to show you what I got here. First, let's do const AWS. So it's going to do a bunch of imports. First, import the SDK, child process, which is built in, and written with an underscore, which I'm not a big fan of, but I guess it is how it is. Const format is equal to require date fns. We'll be using this later. Const fs for the file system. Const path as well, also kind of for the file system, and const util as well. I'll show you how this comes in handy. So then const deployment dir. So this is the deployment directory. It's going to be process.argv2, which is the third thing passed into the command here. So we've got this line here, and let's also do a const deployment dir name is equal to path.basename deployment dir. So this is the name of the directory. Might be API gateway, might be listing service, might be users service. So now we're going to do const rel equals rel path, and this is just a nice little helper function. Path.resolve deployment dir a rel path. So basically, when we write a relative path, it's relative to that deployment directory. So we have that here, and let's do a const tf file path is equal to rel // terraform /terraform.tf state. So this file here, I mentioned this previously, inside of Terraform, we've got terraform.tf state. And like I said, this file should not be committed, but what this file allows us to do is it allows us to see a lot of stuff in terms of how Terraform actually set a lot of things up. And it's really useful here because it contains so much valuable information to help us set it up properly. So this file we're going to reference here. And if we can't find this file, because maybe we haven't done a deployment locally, or the file just doesn't exist here, then we do this tf file path like that. And we throw an error saying Terraform state file does not exist. Have you run? And then Terraform apply like that. Make sure you escape it and then put a semicolon. Mine will reformat to single quotes like that, so that's fine. We do const and then curly braces outputs is equal to json.parse fs.read file sync tf file path, and the encoding is going to be UTF-8. So we're going to read that file, and we have outputs here. Outputs, you'll notice, is this one here, which is our outputs, specifically this section here. So we're going to put this into an object called outputs. So now we have this here. We're going to do require.env.config path rel /.deploy.env. So this is going to be a file which we're going to create in each of the directories. So one for API gateway, one for listing service, and one for users service. So this specifically is going to contain a bunch of deployment environment variables. I'm going to show you how to set that up later on. So now before we continue, we're going to create another file. So inside of node deploy here, Inside of src, let's create a new file and put this one inside helpers/accessenv.js. And you've seen me write this file before. It's pretty much just the same thing I always use, just the cache here around process.env. So we're going to include that file and we're going to use it here. So const accessenv is equal to require.helpers/accessenv like that. So we include this file and then we do const exec equals util.promisify child process.exec. So we're using this in order to basically turn child process.exec, which is a callback function, notice the callback here, into a promise. So this will return a promise, which is a lot nicer because we're going to use async await. So we have that there and we do const get full date. Now I want to use this as well. Format new date, and we're going to basically put it into a nice little time string here, ddhhmmss like that. So that gives us like the full timestamp in like a short, concise format. We're going to get the application name from the environment here. This one comes from deploy.env, which we haven't written yet. I'll show you that later. I'm going to do a max buffer size, which we're going to use later. And we specifically write 1024 times 1024 because that represents one megabyte like that. And then we do const AWS region equals outputs AWS region dot value. Now you'll notice that inside of our outputs here, if we go over to Terraform.tf state, we don't have AWS region. So now we're going to output that real quick. So inside of outputs, we're going to just output the region. So we got output here, AWS region value is equal to, and this one actually comes from var.aws region. So we can just grab that, put that straight here. So the reason that we need this, and before I continue, just make sure Terraform applies, so we have that output, is because we don't really want to have our JavaScript file look through two different places. So it's already looking through a lot of stuff from Terraform TF state, so we kind of want to get all of our Terraform related stuff from there. We don't want to, like, for example, look inside TF vars or look inside some other file for information. Terraform TF state is great for kind of encapsulating that, so that's what we're going to use here. So now let's see if that's done properly. So now we have AWS region here as well, and that appears inside of there. So that's the value we're getting here. And now we're going to set up code deploy. So const code deploy client is equal to new aws.code deploy. I'm going to do this, and we're going to write access key ID, and we access env AWS access key ID. So we're going to put that in there as well. API version is going to be 2014-10.06. The region is going to be the AWS region, and the secret access key is going to be access env AWS access key secret like that. So we have code deploy client. Let's grab this and let's repeat it for S3 client equals new aws.s3. We have this, and then instead of the API version, we're going to do endpoint new aws.endpoint, and we're going to write in here https and then colon / s3 aws region .amazonaws.com. So this is the URL that we're going to use for the S3 endpoint. You kind of have to write it like this. Basically, it does s3.apsoutheast2.amazonaws.com / at the end. So we have this, and we also add in S3 fourth path style is true. And then secret access key, we include that down the bottom. So now we're going to do one more. Root dir equals rel .. So this one will get us into the root directory here, because we're going to be referencing like API gateway, listing service, user service. All of these are one off from the root directory. So that's what we're doing here. We don't have support for it. So we're going to just use an async IIFE, which works just fine. I'm going to do console.log first, and then deploying in 3 seconds. So first and foremost, we give ourselves a little bit of wiggle room here, so that if we want to deploy, we have 3 seconds there to kind of make up our mind whether or not we want to cancel. So then we do here just wait, new promise, resolve, and we're going to just resolve this promise after 3 seconds. So after 3 seconds, we let it continue into the rest of our code. So first thing to do is we check for a file, and we're going to call this one deploy.lock, and it's going to be at the root here. So the reason we have deploy.lock is because we're going to set this up across our listing service, our user service, and our API gateway. So all 3 of these are going to use this whole directory structure, as you'll see very soon. So because we use the whole directory structure, we need to make sure that we're not doing multiple deployment processes at the same time, because we'll have to copy files into the root, do all kinds of stuff. We don't want those to kind of coincide, which is why we have this file here. So then we do a console log. So console.log, checking for log file, like that. And if there is a log file, so log file path like that, if it does exist, then we error log file deploy.log has been found. And then we do halting. So we basically stop it, and we do process.exit to stop it from running. So we put that inside of there, and then we do console.log creating log file. So we create it if obviously we continue and all that. We're just going to do fs.write file sync log file path, and we're just going to write in here, this stops node deploy from running concurrently with itself. Remove this if node deploy complains. Something like that. I think that explains it pretty well. And let's do console.log. Now we're going to do checking environment. So we're going to check for a file called production.env. So if not fs.exist sync, so if we can't find this file, which is .production.env inside of the deployment directory, for example, API gateway or listing service or whatever, then we have to stop. So we do console.error again, node.production.env found, halting like that, and we do process.exit. So we stop there. And now what we're going to do is we're going to write console.log, copying appspec. I want to fs.copy file sync rel.appspec.yaml, and we're going to copy this to /appspec.yaml. So we're going to copy it into the root here into a file called appspec.yaml, and then we're going to do console.log generating deployment file, and we're going to do const file name is equal to backticks deployment dir name hyphen deployment hyphen and then get full date.zip. So this is the name of the file, the deployment file name. We're trying to make it unique. So we have the deployment directory and also the full date so that it stays unique. And then we do const zip path is going to be /tmp and then file name like that. So we're going to put it into the temporary directory when we zip it up. So do that. And then we're going to do await exec. So this is the exec we had up here. If we didn't promisify it, then we would have to use it as a callback function, which is not very neat inside of here. But then we can use exec like this. Zip -r, zip path, and then dot. So we're going to zip up everything in a given current working directory. And then we're going to exclude some files. So firstly, we're going to exclude the whole of Terraform because that's something we do not want to include. -x also node modules. Get rid of everything inside of there as well. -x, and we're also going to do everything inside of a sub node modules directory. So if that does exist, then we also get rid of that. And then -x /or /.cache /or. So this is for parcel. And then -x .git /or. So that's if you have git set up, which I do. -x again /or .ds store. So we do not want ds store anywhere in our application zip file as well. So we have this, that one there, this one, and that one. Okay, perfect, great. So now that we do that, we put a comma, go to the next line, and we do curly braces cwd. So this is the current working directory in which we are going to run this command. So we're going to run this inside root dir because notice it refers to dot, which means the current directory, which is why we want to put it in the root directory. And then for max buffer, we do max buffer size. So we have that, and then we do console.log here, uploading deployment file. Okay, so a quick explanation on the deployment process. We're going to zip up the whole of Microservices demo, excluding a few things, and then we are going to upload this to S3. So that's what we're going to do here, and then do await S3 client.put object. The body is going to be fs.create read stream from the zip path, so the zip file there. The bucket is going to be outputs, square brackets, hyphen, and then application name, and then deployment bucket name dot value. And I'm going to add this in just a second. And the key is going to be the file name, and then do dot promise afterwards like that, because otherwise it uses a callback function by default. But for now, let's just keep going. So console.log upload complete deployment file is, and we're going to write the file name there. And then console.log, we're going to remove the deployment file because we've already uploaded it. So just remove it locally. Unlink sync zip path. And we're going to do console.log deploying application like that. And then await code deploy client dot create deployment. And we're going to write application name. And once again, we're going to include this. So we haven't done anything for code deploy inside of Terraform just yet. We're going to set all of that up after this. So outputs here, backticks, and then application name, once again, hyphen code deploy app hyphen name dot value, and then deployment group name, access env code deploy deployment group name. Revision is going to be, the revision type is going to be S3, and then S3 location, so we specify the bucket again, so outputs, we can just grab that same bucket here, so it's the same bucket there, put that in here, and we're going to write bundle type is going to be a zip file, because that's what we created, and the key is going to be the file name, so same as this file name here, and just do .promise here again, and we're going to do console.log deployment initiated on code deploy, like that, and then console.log cleaning up, and we're going to unlink a few files, which means delete. So unlink sync rel./deploy.log, so we want to get rid of that, and also get rid of aspect.yaml. So now that you've written this whole thing, there definitely is a lot of stuff in here, I'm sure, that you don't understand or that currently does not make sense. But what we're going to do now is go back into Terraform and add in support for code deploy, which should start to make a lot of this stuff start to make sense. So now here inside of Terraform, we're going to create a new file inside of code deploy -app /variables.tf. So now inside of this file here, we're going to do variable app name. So we're going to take in the name of the app, which is going to be a string, and then variable, if I can spell that, EC2 instance name, which is going to be type equals string, like that as well. So now inside of here, right click new file, call it main.tf, and we're going to create resource AWS code deploy app, and then default like that. The compute platform is going to be server, and then the name is going to be var.appName. So this comes from variables here. And we're going to go here, right, resource AWS code deploy deployment group, and we're going to set this one to prod, which basically just means production. App name is going to be AWS code deploy app.default.name. The deployment group name is going to be prod. We're going to add a service role ARN is equal to AWS IAM role.codedeploy role.arn. I'm going to add that in very soon. EC2 tag set, EC2 tag filter. So basically what this does is this allows us to pick a specific EC2 instance to deploy to. So this one's going to take in a key equals name, type equals key and value. So the key and the value both have to match. Value equals var.ec2 instance name. So basically what this means is this allows us to find the EC2 container that we're going to deploy to inside of code deploy. So we've got this here, and now we're going to create this IAM role. So let's go up to the very top and let's add in resource AWS IAM role, add in code deploy role here. And name is going to be, now look at the name here, we're going to do var.appName and interpolate it like that, and then code deploy role. Now before we continue, this name here kind of matches the same syntax, you'll notice, as names inside of our node deploy. So we actually have a lot of stuff which kind of does hyphen code deploy app name hyphen like that with the application name at the start. So that's the same idea here, is that we have this kind of naming convention where we have the app name at the beginning, hyphen, and the code deploy stuff and so on like that. So we're going to do assume role policy, and this one is important for code deploy. Going to write this here, curly braces, and then version is going to be 2012-10-17. This is part of the AWS permissions policy stuff. So statement here, we're going to write curly braces, SID is going to be empty, effect will be allow, principal, and then service is going to be code deploy.amazonaws.com, and then comma, action, going to write STS, assume role like that. And we're going to go here and we're going to write resource AWS IAM role policy attachment, and we're going to write AWS code deploy role policy ARN is equal to, and write this carefully, ARN colon AWS colon IAM colon AWS colon policy / service hyphen role / AWS code deploy role like that. So this is going to be a built-in code deploy role, which we have to attach to our code deploy. We have to attach it here, otherwise it won't work properly. So we have to attach this policy to this role, which the role we then attach to our production deployment group, otherwise nothing will work. So we have to do that, and then we do role is equal to AWS IAM role .code deploy role .name. So we do that, we have this, and we have this set up inside of main.tf. Now we actually still have quite a few things missing inside of code deploy app. So let's create a new file here, do s3.tf, and this one's going to be our S3 bucket. So resource AWS S3 bucket, we're going to call this one deploy bucket internally, and the bucket name will be microservices -demo and then var.app name like that, and then -deployment. So this just allows us to get a unique bucket name. Now, if everyone uses the same name, the problem is that you'll quickly get a clash because on S3, bucket names are unique globally. So you have to kind of use a different bucket name. So for your one, you might choose to write your name at the front, like Lucas Microservices Demo. Just do whatever you see fit. But if you use this, it most likely will break on you, just letting you know. So anyways, we're going to do that. And we're going to add in some other stuff into here, which is specifically going to be used into our EC2 instance, because the way it works is we have certain permissions given to our code deploy deployment group, right? And that allows us to initiate the deployment. However, in order for the EC2 container to receive the deployment and to actually use it, it needs to have its own permissions attached properly. So that's what we're going to set up inside of here, which we're then going to attach into our Node server. So inside of code deploy app, let's create a new file. For this one, iam instance policies.tf. And inside of here, we're going to do resource AWS IAM instance profile EC2. Name is equal to var.app name and then -EC2 like that. And then role equals AWS IAM role.ec2.name. So this one here we're going to add, and then right click again, new file, IAM role policies.tf. So this is the code we're going to write into here. Resource AWS IAM role policy, and we're going to do S3 deployment policy there like that. Name is equal to var.app name like that, -deployment -S3, role equals AWS IAM role.ec2.id. So now that we have that, IAM roles, this one here, well, it's going to be attached to the same thing as this one here, which we're going to create later on. And our policy is going to be EOF like that and EOF here. Now this section of code, essentially everything here was boilerplate that I got from the internet. So these ones here basically means that we're going to give our EC2 container access to all of these resources. Now these are the built-in AWS code deploy buckets. You have to give it access to all of these. And then we also add in our custom bucket, which is our deployment bucket, which we've set up inside of here. So it needs to have access to this, and it needs to have access to all of these. So now that we've done this, we can save this file. Right click here, one more file, call this one iamroles.tf. I lied, there's actually one more file after this one, but anyways, we have this here. And inside of here, we're gonna write resource AWS IAM role and then EC2. So this is the EC2 role, which the policy then attaches to. So that one attaches to it, and the instance profile also attaches to it as well. I wrote policies here. This one should probably be profile. So instance profiles, not policies, profiles.tf. And then inside of iamroles.tf here, we're going to write name equals, and then var.app name, and then EC2 like that. Path is going to be a root, / there like that. Assume role policy is equal to EOF like that. And this one here, curly braces, version, and then 2012, 1017, statement, and then like that, action, STS, assume role, principal again, service. This time it's going to be ec2.amazonaws.com. Effect is going to be allow, and SID is going to be an empty string. So we have this code here inside of this file. Now let's right click here, one more file, call this one outputs.tf, and this is going to produce some outputs from our modules. So we're going to output app name and the name of the app. So value equals AWS code deploy app.default.name _ app.default.name. And then go here, output deployment bucket name, value equals AWS S3 bucket.deploy bucket.id. So this is the name of the deployment bucket. And then output IAM instance profile, value is equal to AWS IAM instance profile.ec2.name. So this one we're going to output here as IAM instance profile. Now what we're going to do with this is go into, say, for example, API gateway here. Firstly, we're going to go here and write module API gateway code deploy. So we're going to include this one. So source code deploy app. And then do app name is equal to API gateway. And then EC2 instance name equals module.api-gateway.name. So we're going to pass in the name into here, which allows us to deploy to this EC2 instance. And inside of here, we're going to add in IAM instance profile is equal to module Node.API gateway code deploy.im instance profile. So we're going to add in this because this then allows us to have access to code deploy from our Node server. So we kind of like specify this this inside of here using the name in order to deploy to it. And in order to get the deployment working properly, we have to specify the IAM instance profile, which we get from here. So now we have that both ways. Let's go into listings service, and you pretty much do the same thing. So let's grab this section here from that, and let's change API gateway into listings service code deploy like that. And then let's grab this line IAM instance profile, paste it here. And then instead of writing API gateway code deploy, we're going to write listings service code deploy like that. And then now we're going to do one more for the users service. So grab these lines here, paste that right there, and rename this one to users service. And then we're going to grab the IAM instance profile, paste it there, and rename this one to users service code deploy. So now we have the IAM instance profile set up for all three of these. You'll notice that inside of Node deploy here, inside of index.js, let's have a look at the outputs we're actually using. So we're using AWS region, and then down here you'll notice that we're using the application name, deployment bucket name, so we need to specify that. Also the code deploy app name, so those are the other two that we're using here. So in order to get those, let's go into outputs.tf, and then for our API gateway, let's first specify the deployment bucket name. So output API gateway deployment bucket name. And the value of this is going to be, inside of API gateway, we have our code deploy. So we're going to do module.api gateway code deploy. And then let's grab the name. So that comes from code deploy app. Outputs here, we have deployment bucket name. So we're going to grab that, put that here. And we also have a code deploy app name, which we need. So we're going to grab the same thing, put it 2 lines above because first starts with C. So code deploy, and we're going to write app name like that. So API gateway code deploy app name, which gets code deploy app name just like that. So it just gets the app name, not code deploy. Anyway, so that one there gets this one here, which goes to API gateway code deploy app name, which then can get resolved by this. So we grab these 2 bits here and we do the same thing for our listings service. So we put it inside of here, grab that, do that, listings service like so. Grab that, go down here, paste it, and replace this one with users service. So now we have additional output, which essentially helps us get Node deploy working properly. So now that we have this, I'm pretty confident that we can go back into terminal, do Terraform apply first. And we need to do Terraform init because we added new modules. Seems like we have some problems in IAM role policies. So probably just, I mistyped something, put a semicolon. Yep, so get rid of that semicolon there. And then let's run this one more time. Do Terraform apply. So it seems like we're getting some errors, and mine is because my bucket name is not unique. So I just need to go here and rename my bucket. So I'm going to call this one Lucas Microservices demo that, and that should allow us to get some unique bucket names. So now let's try this one more time. Okay, great. So now we have all our stuff created. We've got this stuff for API gateway, listing service, and users service. So now that we have all of this set up, now you notice inside of Node deploy here, we actually also reference some stuff for the M's. So we haven't created that just yet, and we're going to do that now.